Cloud financial management, or FinOps, is one of the fastest growing disciplines in technology right now. And if you work in finance, business analysis, program management, or any role that sits along cloud and technology teams, you're going to encounter this vocabulary constantly. But in steering committee meetings, even in board conversations, or you see them in job descriptions as well. The problem is that most of the resources that explain FinOps are written for cloud engineers. They assume you already understand infrastructure. They use technical jargon without defining it. And they make finance professionals feel like outsiders in conversations that are actually about money. This video is different. I'm going to give you 5 FinOps terms defined in plain English with a specific focus on what each one means from a finance professional's perspective. No cloud engineering background required, just your analytical mind and your existing financial literacy. My name is Kemi Thompson. I've spent over 20 years working across business analysis, FinOps, cloud architecture, and program management in UK and private sector organizations. I founded beopodly.tech to help non-technical professionals develop the vocabulary and frameworks they need to operate confidently in tech environments. Let's get into the terms. Let's start with the term that underpins everything else in FinOps, and that's cloud unit economics. The definition is quite straightforward. It is the cost your organization pays to complete one unit of meaningful work in the cloud, not the total cloud bill. Unit might be one customer transaction processed, one report generated, one invoice sent, one API call completed. The specifics depend on your business, but the principle is universal. Here is why this matters to finance professionals. Without unit economics, cloud spend is just a number. Your cloud bill says you spent £420,000 last month, but what did you get for it? Cloud unit economics answers that question. It turns the bill into a rate, the cost per transaction, the cost per report, the cost per customer served. And a rate is something you can benchmark, forecast, and improve. A bill is just something you pay. Term 2, show back versus chargeback. These two words describe two very different approaches to the same problem. How do you make business teams accountable for the cloud cost they generate? Showback means you calculate what each team's cloud usage cost and you show them that number. You present a report. You say, here is what the marketing team's data pipelines cost this month, £42,000. They see it, they note it, they are not billed for it. Chargeback is the next step. Instead of showing the team their cost, you actually transfer those costs to their budget. The £42,000 comes off the marketing's budget allocation, not a central IT pot. Now, the conversation changes entirely because when a team sees a number, they might care. However, when that number affects their budget, they always care. Most organizations start with showback. It is gentler, requires less internal political negotiations. Mature FinOps programs move towards chargeback because it produces better cost behavior. Term 3. Cloud providers offer two main ways to pay for compute resources. On-demand pricing means you pay the full rate as you use it, with no commitment. It is the most expensive option, but the most flexible. Reserved pricing means that you commit to using a certain amount of cloud resource for 1 year or 3 years, and in exchange, the provider gives you a significant discount. AWS calls them reserved instances. Azure calls them reserved V instances. Google Cloud calls them committed use discounts. The name varies, however, the concept is identical. For finance professionals, reserved instance is essentially a capital commitment in exchange for a discount. The mental model that works best is the hotel analogy. If you pay per night, you pay full rate. If you book 30 nights in advance, you get a lower per night. If you buy a monthly membership, you get the best rate, but you are committed to paying whether you stay or not. That last part is the risk in reserved instances. If you commit to a 3-year reservation, and your workload changes, you may end up paying for capacity you are not using. The FinOps analyst job is to match commitment to actual usage pattern to maximize discount without overcommitting. Now to the fourth term, cost allocation and tagging. This is one of the most practically important FinOps concepts for finance professionals to understand because it is what makes a cloud bill interpretable. A cloud bill is a list of resource types and costs. You spent £84,000 on compute instances. You spent £12,000 on storage. The bill is accurate, but it is also completely uninformative. You cannot tell which business unit generated those costs, which project drove the usage, or which product the spend supported. Tagging solves this. A tag is a label you attach to a cloud resource that attributes it to a specific team, project, or cost center. When tagging is done well, every resource in your cloud environment carries metadata that lets you slice the bill any way you need, by team, by environment, by product, even by geography. The finance director can see exactly what marketing, engineering, and finance each spent. In practice, tagging is one of the most persistent challenges in FinOps. Teams forget to tag new resources. Tags become inconsistent. Different people use different conventions. Shared infrastructure is genuinely difficult to attribute. And a significant part of FinOps analyst work is building the governance process that make tag consistent and complete. When engineers provision cloud resources, they almost always provision more than they need. And in this instance, provisioning means sizing up a server capacity. There is very understandable reason for over provisioning the servers. It's because nobody wants to be the person who undersized a server and caused a performance incident. So the default is to pick the larger option, build in a buffer, and move on. The result at large scale across an organization is significant waste. You end up with servers running at 4% of their capacity, databases provisioned for 10 times their actual load, and storage tier that were chosen for a use case that never materialized. Right sizing is the practice of identifying those over-provisioned resources and reducing them to a size that actually matches the workload. The objective is the same output at lower cost. A server with 32 CPUs running at 4% utilization is doing the same work as an 8 CPU server running at 18%. But the 32 CPU server costs roughly 4 times as much. Right-sizing recommendations, one of the outputs that FinOps analysts generate from monitoring data and implementing them consistently, is one of the fastest ways to reduce cloud spend without changing anything about what the business needs. And that covers 5 terms for today. Cloud unit economics, showback versus chargeback, reserved instances, cloud allocation and tagging, and right sizing. 5 terms that will make you a more confident presence in any cloud financial conversation. If you want to go deeper, the link to the free quiz is in the description. It will tell you which tech career path fits your background. Also, I have the FinOps Analyst Career OS, which is an interactive guide that helps you with understanding what the day-to-day task and expectation of a FinOps analyst is. Subscribe for more. I'll see you on the next video.